We are continuing the Math 4 review. We are now on number 18A. It's asking us to add or subtract these radical expressions and simplify if possible. Again, that means no calculators. We are simplifying our radicals and then combining our like terms. So the first thing I want to do on A is look for, I'm not quite sure if you caught that, but my phone started ringing, so I went out for a second, got my phone call, and I'm back. So if you saw a little hesitation, that's what was going on there. I think what I was saying when I left was that I'm looking for perfect square factors under my radical sign. So if I can think of them, then that's all I need to do is just write them down as perfect squares and whatever's left, whatever the other factor is. If you don't recognize that, then prime factor each of the numbers, looking for two identical factors. But I think on these we can probably figure out what they are. 75 is 25 times 3. So if I write it that way, I'm going to be able to see what I can take the square root of to take out of the radical sign. So that's going to be minus 4 times, and again 50 is 25 times 2. And 27 is 9 times 3. So on each of those I found a factor that was a perfect square number and a leftover. Now it's not always going to work out perfectly like that. Sometimes you may have to prime factor it to find two of any one particular factor, but these turned out to be pretty easy ones. So now I'm going to go back and take the square roots. The square root of 25 is 5, so I bring that out and multiply by what's already out there. I've used it, so that all that's going to be left under that, of course, is the 3. Now I'm going to do the same thing on this one. The square root of 25 was 5, so I bring that out and multiply it by the 4 outside there. I've used it, so it's gone, but I do still have the square root of 2. And now again, 9 is a perfect square. Its square root is 3, so I bring that out. There was nothing out here already to multiply it by, so it's out there by itself, times the square root of 3. So the next thing I'm going to do is multiply the factors that I brought out that already had a factor there to multiply by. So that's now 10 times the square root of 3 minus 20 times the square root of 2 plus 3 times the square root of 3. So now I want to combine my like radicals, and remember, just like when we're adding like terms, when we're talking about variables, they have to be exactly the same variable raised to exactly the same power to be considered like terms, and then I would add or subtract the numbers in front. Well, with like radicals, they have to have exactly the same index. This is a square root, so my index is 2, and exactly the same radicand, which is the number under the radical sign. So you can see this and this are like radicals. They're both square roots, and the radicand is 3 on both of them. This one is not. While it does have the same index, it is a square root. The number under the radical sign, or the radicand, is not the same. So these two are like terms. I can just combine them. That gives me 13 times the square root of 3 minus 20 times the square root of 2, and that's simplified as far as I can go. So moving on to B, I'm going to do exactly the same thing. I'm going to rewrite my radicals so that I have a perfect square and another factor if that works out. And 50, of course, we've already said is 25 times 2 minus 5 times the square root of 12 is 4 times 3, and the square root of 18 is 9 times 2. So it worked out pretty well again. Whoops, I don't see my times sign in there. Okay, so now I'm going to go in and take the square roots that I can. I can take the square root of 25, it's 5. So I have 10 times 5 times the square root of 2. I can take the square root of 4, it's 2, so that comes out 5 times 2 times the square root of 3 minus 5. And here I can take the square root of 9, it's 3, so I have 5 times 3 times the square root of 2. Again, in this step, I'm going to multiply what I brought out. Now, if you wanted right here to have said the square root is 25, take it out and multiply by 10, and get 50, you could have done all that in one step. I'm just trying to make sure you see what I'm doing. So that gives me 50 times the square root of 2 minus 10 times the square root of 3. And again, you could have said the square root of 4 is 2 times 5 is 10, skipped this middle step and gone right here. and that's minus 15 times the square root of 2. So again, just like I did in problem A, I'm looking for like radicals. I have 50 times the square root of 2 and 15 times the square root of 2. The fact that they're both square roots, meaning my index is the same on both, and the radicands in both are 2, those are like terms. 10 times the square root of 3 is not a like term because it has a different radicand. So I can subtract the numbers in front of my radical signs. 50 minus 15 is 35 times the square root of 2 minus 10 times the square root of 3. Remember, when you're adding or subtracting, it's just like terms. You add the coefficients in front and you keep the radicands the same. Not the radicands, the radicals. Radicand is just a number underneath. And so that's my final answer. Okay, we're moving on to multiplication of radical expressions. In 19a, I have a single radical multiplied by a binomial with radicals, which means I just use my distributive property. So I have square root of 10 times the square root of 7. Remember, when you're multiplying radicals, whatever's under the radical gets multiplied together. So that becomes the square root of 70. Nothing on the outside because I didn't have anything on the outside. Plus, again, I'm multiplying the square root of 10 times the square root of 11. Anything under the radical sign can be multiplied together, so that's the square root of 110. So now I need to check if I can simplify these. Well, I'm not going to look at 70 and 110. I'm going to look at the numbers that I started with. So 10 was 2 times 5, and 7 was prime, so it's just 7. So that means 70's factors are 2, 5, and 7. There aren't 2 of anything, so that is simplified as much as it can be. And also with 11 and 10, again 10 is 2 times 5, 11 is prime, so I have 2 times 5 times 11. There are not 2 alike factors, so that's my final answer on that. That's all I needed to do. Okay, on B, I am foiling because I have a binomial times a binomial. So in my first, I have 8 times the square root of x times 9 times the square root of x. Remember, the rule is multiply what's outside the radical. 9 times 8 is 72. Multiply what's under the radicals. X times x is x squared. If you recognize that the square root of x squared is x, you can do that in that first step. Now I'm doing outer. 8 times the square root of x times 4. Multiply what's outside the radical. That's 32 times the square root of x. Whoops. Forgot my radical sign there, didn't I? Now I'm doing my inside. 5 times 9 times the square root of x. 9 times 5 is 45 times the square root of x. And last, 5 times 4 is 20. And that gives me plus 20. So now I have to collect my like radicals. A little bit hard to see here since I didn't draw that one real well. But 32 times the square root of x and 45 times the square root of x are 77 times the square root of x. You add the numbers in front. Doing it again, forgetting my radical. Bring down the plus 20. And here, remember, the square root of x squared is x, so that's 72x. I look to see if I have any like radicals, and I don't, because the only radical I have left is the middle one, 77 times the square root of x. There are no other radicals, so I can't combine any of those. The first term has an x and the last term doesn't, so also I can't combine those, and that's my final answer.